September 200 caved, 1944. The morning mist still clung to the Dutch countryside near Arnhem as Obergefreiter Klaus Mueller crawled through the abandoned American foxhole, his hands trembling not from cold, but from what he had just witnessed. Behind him, scattered across 50 meters of blood-soaked earth, lay the remnants of his machine gun section. 8 men, reduced to 3 in less than 2 minutes of sustained fire from a weapon that should not have existed. Mueller's eyes fell upon the massive machine gun mounted on its tripod, still warm to the touch, ammunition belt trailing across the muddy ground like a mechanical serpent. The weapon was enormous, far larger than any machine gun he had ever seen, yet somehow the Americans had operated it with just 2 men. His MG42, pride of German engineering, lay silent 30 meters away, its crew dead around it, victims of a firepower demonstration that would haunt Wehrmacht veterans for decades to come. This was not supposed to happen. German machine gun doctrine, refined through 5 years of warfare, proclaimed the MG42 as the finest automatic weapon in the world. At 1,200 rounds per minute, it had earned the nickname Hitler's buzzsaw from Allied forces who dreaded its distinctive sound. Yet here lay proof that American industrial might have produced something even more devastating. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Mueller approached the American weapon cautiously, studying its construction with the professional eye of a machine gunner who had served from Stalingrad to Normandy. The receiver was massive, built like a fortress rather than the elegant mechanical precision of German design. The barrel, as thick as his wrist, showed no signs of overheating despite evidence of prolonged firing. Most shocking of all, the ammunition was .50 caliber, each cartridge longer than his thumb and thick enough to penetrate light armor. The implications struck him like a physical blow. This was not merely a machine gun, but an anti-material weapon capable of destroying vehicles, fortifications, and aircraft. Yet the Americans had deployed it against infantry as casually as the Wehrmacht used the MG42. The mathematics were simple and terrifying. If the enemy could afford to use such weapons against foot soldiers, what did that say about their overall military production? To understand how this moment of revelation came to pass, we must examine the parallel development of German and American machine gun philosophy in the years leading to the Second World War. The roots of this technological confrontation stretched back to the closing days of World War I, when both nations drew vastly different conclusions from the same bitter lessons. In 1918, as the Great War ended, German military engineers possessed arguably the world's finest machine gun designs. The MG8, a water-cooled weapon firing the 7.92mm Mauser cartridge, had dominated the Western Front. Its reliability and accuracy were legendary, but the weapon system weighed over 60 pounds and required a crew of 4 to 6 men. As Germany entered the interwar period, restricted by the Treaty of Versailles from developing military technology, their engineers continued working in secret. The goal was clear: create a lighter, more mobile machine gun that retained the devastating effectiveness of the MG8 while allowing rapid repositioning on the battlefield. By 1934, as Germany openly began rearmament, the MG34 emerged as the world's first truly universal machine gun. At 26 pounds, it could serve as both a light machine gun with bipod and a heavy machine gun on tripod mount. The MG34's rate of fire reached 800 to 900 rounds per minute, making it faster than most contemporary weapons. Its quick-change barrel system allowed sustained fire without overheating. Most importantly, German production philosophy emphasized precision manufacturing and high-quality materials. Each MG34 was crafted to exacting standards, virtually hand-fitted by skilled workers who took pride in mechanical perfection. This approach reflected German military culture's emphasis on superior engineering and individual weapon quality. German doctrine assumed that better-designed weapons, operated by highly trained soldiers, would overcome any numerical disadvantage. The MG34, and its successor, the MG42, represented the pinnacle of this philosophy. Meanwhile, across the Atlantic, American military planners were drawing entirely different conclusions from the Great War's lessons. The United States had mobilized massive industrial capacity to support the war effort, transforming from a predominantly agricultural nation to an industrial powerhouse in less than 2 years. This experience taught American leaders that modern warfare was fundamentally about production capacity rather than individual weapon superiority. John Moses Browning, whose designs had already revolutionized small arms, began work on a heavy machine gun in 1918. His vision was radically different from German philosophy. Rather than creating the most mechanically sophisticated weapon possible, Browning designed for mass production, mechanical simplicity, and overwhelming firepower. The 50 caliber Browning machine gun cartridge, designated 50 BMG, measured 12.7 mm in diameter and 99 mm in overall length. This massive round delivered more than 6 times the kinetic energy of standard rifle cartridges. The projectile alone weighed between 620 and 710 grains, compared to 150 grains for the German 7.92 mm round. The M2 machine gun, perfected by 1933, was built around this devastating cartridge. The weapon weighed 84 pounds for the receiver group, with an additional 44 pounds for the M3 tripod. While significantly heavier than German designs, the M2 delivered firepower that transcended traditional machine gun roles. At maximum rate of fire, the M2 could sustain 450 to 575 rounds per minute. While slower than the MG42, each round carried exponentially more destructive power. The effective range exceeded 2,000 meters against point targets, with area suppression possible beyond 7,000 meters. Most critically for infantry combat, the massive kinetic energy made any hit instantly fatal. American production philosophy differed fundamentally from German approaches. Rather than emphasizing individual weapon perfection, American designers prioritized standardization, reliability, and mass production. Every M2 component was manufactured to specifications, allowing complete interchangeability. Any part from any M2 would fit any other M2, regardless of manufacturer or production date. This approach meant American industry could produce M2 machine guns in quantities that German engineers considered impossible. By 1941, American arsenals contained thousands of M2 machine guns. German intelligence, focused on technical specifications rather than production capacity, failed to grasp the implications of American mass production philosophy. German weapons development continued, emphasizing technical sophistication over quantity. The MG42, introduced in 1942, represented the peak of German machine gun design. At 1,200 rounds per minute, it fired faster than any contemporary weapon. The roller-delayed blowback operation was mechanically elegant, requiring fewer moving parts than most designs. Manufacturing costs per unit were lower than the MG34, but production still required skilled workers and high-quality materials. Each MG42 was essentially a precision instrument, beautifully designed and carefully manufactured. German military culture took pride in deploying weapons that represented the finest engineering achievements possible. This pride blinded German planners to the strategic implications of American production methods. Intelligence reports from 1942 estimated American heavy machine gun production at perhaps several hundred per month. German estimates assumed American weapons would be inferior copies of European designs, produced by unskilled workers using substandard materials. The reality was staggering. By 1943, American industry was producing over 3,000 M2 machine guns monthly. By 1944, production peaked at nearly 5,000 per month. Total wartime production exceeded 200,000 weapons, supported by billions of rounds of 50 caliber ammunition. More importantly, American doctrine deployed these weapons differently than Germans used their machine guns. German doctrine treated machine guns as specialized weapons, requiring carefully trained crews and specific tactical employment. The MG42 was typically deployed in planned positions, with prepared fields of fire, supported by infantry and coordinated with artillery. American doctrine treated the M2 as a flexible support weapon, distributed throughout the force structure. Infantry companies received M2 machine guns for direct support. Tank destroyers mounted them for anti-aircraft protection. Engineers used them for bunker reduction. Artillery units employed them for perimeter defense. The Americans were using what amounted to anti-tank weapons as general-purpose infantry support. This philosophical difference reflected broader contrasts between German and American military thinking. German doctrine emphasized tactical excellence, superior training, and weapon quality. American doctrine emphasized overwhelming firepower, reliable logistics, and numerical superiority. Both approaches had proven successful in different circumstances, but they had never before clashed so directly. The first encounters between German MG42 teams and American M2 positions occurred during the Italian campaign in late 1943. German after-action reports from Monte Battaglia and San Pietro described American heavy machine guns with puzzled respect. Obergefreiter Ernst Hoffmann of the 29th Panzer Grenadier Division wrote to his brother, "The Americans possess machine guns of extraordinary power. The sound alone is different from anything we have encountered. When they fire, the noise is like continuous thunder rather than the sharp crack of proper automatic weapons." But it was in Normandy that German machine gunners first truly comprehended what they faced. The hedgerow country of northwestern France became a laboratory for comparing machine gun effectiveness. German MG42 teams, expertly positioned in prepared positions with excellent fields of fire, found themselves consistently outgunned by American weapons they could not identify or understand. Hauptfeldwebel Wilhelm Gross, a veteran machine gun instructor with over 4 years of combat experience, encountered his first M2 during the fighting for St. Vith in July 1944. His detailed report, discovered in German military archives in 1978, provides crucial insight into German perceptions. Position established at 0600 hours overlooking American assembly area. MG42 emplaced with excellent fields of fire extending 800 meters. American infantry began advancing at 0730. Opened fire at 600 meters with devastating effect. Americans took cover and returned fire with automatic weapons of unusual intensity. Their tracers appeared larger than standard, burning brighter and lasting longer in flight. After approximately 10 minutes of engagement, American fire intensified dramatically. Single weapon, positioned approximately 400 meters to our front, began firing continuously. Sound was unlike any machine gun previously encountered. Individual rounds struck our position with explosive force, penetrating sandbag protection and destroying stone walls we considered adequate cover. Ammunition appeared to be anti-tank or anti-aircraft caliber, but weapon fired automatically like machine gun. Rate of fire lower than MG42, but individual rounds possessed devastating effect. Forced to abandon position after American weapons systematically destroyed all available cover. Casualties: 3 killed, 2 wounded. American advance resumed immediately. Gross's report was forwarded through Wehrmacht channels, eventually reaching machine gun training schools in Germany. The response was predictable. American forces must have deployed anti-aircraft guns in ground support roles, an improvisation suggesting desperation rather than doctrine. German military thinking could not accept that the Americans were routinely using what amounted to anti-material weapons for infantry support. This misunderstanding persisted until September 1944, when Wehrmacht forces captured intact American positions near Arnhem during the failed Operation Market Garden. For the first time, German technical experts could examine American heavy machine guns in detail, study their ammunition, and analyze their tactical employment. The examination began at 0800 hours on September 24, 1944. Hauptmann Friedrich Steiner, Wehrmacht ordnance specialist attached to the 9th SS Panzer Division, approached the captured American position with scientific curiosity and growing apprehension. Behind him walked Obergefreiter Mueller and the 2 surviving members of his machine gun section, men whose world had been fundamentally altered in those devastating minutes of American fire. The M2 Browning sat exactly where its crew had abandoned it, surrounded by evidence of sustained combat. Empty ammunition cans littered the position, each marked with American military specifications. Steiner counted 14 empty containers, each originally holding 100 rounds of 50 caliber ammunition. 1,400 rounds expended from a single weapon position. The implications were staggering. German machine gun doctrine emphasized ammunition conservation. MG42 crews were trained to fire in short, precise bursts to prevent barrel overheating and conserve ammunition. Sustained fire was reserved for desperate defensive situations, yet here was evidence that American crews routinely expended ammunition quantities that would supply a German section for weeks. Steiner's technical examination revealed construction principles that challenged everything German ordnance specialists believed about machine gun design. The receiver was machined from solid steel billets rather than assembled from stamped components. Every surface showed evidence of precision manufacturing to tolerances that German wartime production could no longer achieve. The weapon was built like a piece of industrial machinery rather than a portable infantry weapon. The barrel measured 45 inches in length, with a bore diameter precisely 12.7 millimeters. Wall thickness exceeded anything German engineers considered necessary for small arms. When Steiner attempted to lift the barrel, he required assistance from 2 soldiers. This single component weighed more than the complete receiver group of an MG42. Yet examination of the bore showed no signs of erosion despite obvious heavy use. Most shocking was the operating mechanism. German machine guns utilized either short recoil operation like the MG34 or roller-delayed blowback like the MG42. Both systems required careful timing and precise manufacturing tolerances to function reliably. The M2 used short recoil operation, but with components massively over-engineered compared to German practice. The bolt alone weighed over 5 pounds, compared to less than 1 pound for MG42 components. Every moving part was designed with factors of safety that German wartime economy could not afford. Where German designers had optimized for minimum material usage and manufacturing efficiency, American designers had apparently ignored cost considerations entirely, building weapons that could function under conditions that would destroy more economical designs. Obergefreiter Mueller, examining ammunition scattered around the position, made discoveries that would reshape his understanding of American military capability. Individual cartridge cases measured 4 inches in length, dwarfing the 2.24-inch cases used by German machine guns. The brass showed no signs of stress or deformation despite obvious use, indicating manufacturing quality that exceeded German standards. But it was the projectiles themselves that truly revealed American intentions. Mueller found 3 distinct types of 50 caliber ammunition: ball, armor-piercing, and armor-piercing incendiary. The ball ammunition alone weighed 660 grains, over 4 times heavier than German machine gun bullets. The armor-piercing rounds featured tungsten carbide cores, capable of penetrating 3/4 of an inch of hardened steel at 500 yards. These were not anti-personnel rounds. They were anti-vehicle projectiles, designed to destroy light armor, aircraft, and fortifications. Yet the Americans were using them against infantry as routinely as Germans used standard rifle ammunition. The material waste implied production capacity beyond German comprehension. Steiner's most disturbing discovery came when examining the weapon's sighting system. The M2 mounted telescopic sights graduated to 2,000 meters, with provisions for indirect fire beyond 7,000 meters. German MG42 sights were optimized for 800-meter engagements, reflecting realistic battlefield ranges. American weapons were apparently designed for ranges that exceeded normal infantry combat by enormous margins. Testing the weapon's mechanical function proved equally revealing. Despite obvious heavy use and exposure to combat conditions, every component operated smoothly. The charging handle moved with mechanical precision. The safety engaged and disengaged without hesitation. Most impressively, the quick-change barrel system allowed complete barrel replacement in under 30 seconds, faster than similar operations on German weapons. Steiner's technical report, forwarded to Wehrmacht headquarters on September 26, contained assessments that would influence German military thinking for the remainder of the war. The captured American machine gun represents design philosophy fundamentally different from German practice. Where we have optimized for efficiency, mobility, and economic production, the Americans have optimized for durability, firepower, and operational flexibility without apparent regard for cost or weight considerations. The weapon's construction suggests manufacturing capability that exceeds our current capacity. Machining tolerances, material quality, and component design all indicate industrial processes that we cannot match under wartime conditions. Most significantly, the ammunition expenditure evidenced at this position suggests logistical support capabilities that are strategically decisive. But technical analysis told only part of the story. The psychological impact on German machine gunners who examined the captured weapon was equally significant. These were men who had been trained to believe German engineering represented the pinnacle of military technology. The MG42 was not merely a weapon but a symbol of German technical superiority, proof that superior design could overcome material disadvantages. Obergefreiter Hans Weber, sole survivor of the machine gun crew that had faced the M2, struggled to reconcile what he had witnessed with everything he had been taught. In a letter to his wife, written on September 28th and intercepted by Allied intelligence, he wrote, "We always believed our weapons were the finest in the world. The MG42 fires faster than any other machine gun, and we took pride in that speed. But what good is firing fast when each of their bullets hits like a small artillery shell? I watched their tracers punch through stone walls that would stop our bullets completely. When they fired at our position, chunks of masonry exploded around us like grenades. Heinrich was hit by a single round and simply disappeared. There was nothing left to identify. How do you fight against weapons that can do this?" The captured weapon became the center of intensive study by German technical personnel throughout the autumn of 1944. Engineers from Rheinmetall, Mauser, and other German arms manufacturers examined every component, seeking insights that might improve German production. Their conclusions were uniformly pessimistic. Oberingenieur Karl Brenner of Rheinmetall wrote in his technical assessment, "The American weapon represents manufacturing philosophy that is alien to European practice. Every component is oversized, over-engineered, and manufactured to tolerances that require machine tools we do not possess in sufficient quantities. We could duplicate the design given unlimited resources and time, but we cannot duplicate their production methods." More critically, the ammunition represents raw material consumption that we cannot match. Each 50 caliber round requires more steel and brass than 5 of our standard cartridges. The Americans are treating ammunition as an unlimited resource, allowing them to employ weapons we could never afford to fire. German attempts to reverse engineer captured M2 components revealed the extent of American industrial advantages. The steel alloys used in critical components required materials that were increasingly scarce in wartime Germany. The precision machining demanded equipment that was being used for aircraft production. Most frustratingly, even when German engineers could manufacture individual components, they could not achieve the production volumes necessary for meaningful military impact. By October 1944, Wehrmacht ordnance had examined dozens of captured M2 machine guns. Every examination reached the same conclusion. The Americans possessed weapons that represented a fundamental shift in military thinking. They had abandoned the European emphasis on efficiency and optimization in favor of overwhelming firepower supported by unlimited logistics. The strategic implications began penetrating German military planning. If American forces could afford to use anti-material weapons against infantry, what did that suggest about their overall production capacity? Intelligence estimates of American military production were revised upward repeatedly throughout the autumn of 1944, but every revision proved conservative. Oberst Heinrich Müller, no relation to the machine gunner, served as Wehrmacht liaison to German intelligence services. His report, dated November 3, 1944, provided brutal assessment of the situation. Captured American weapons suggest industrial capacity that exceeds our most pessimistic estimates. The enemy is deploying what amount to specialized anti-tank weapons as general infantry equipment. This implies production volumes that make prolonged resistance mathematically impossible. If the Americans can afford to expend ammunition at current rates indefinitely, while our own production continues declining, the outcome becomes inevitable regardless of tactical skill or defensive preparations. We are not merely fighting superior numbers, but superior industrial capacity that makes numerical equality impossible to achieve. The psychological impact on German machine gun crews extended far beyond technical assessments. These men had staked their professional identity on operating the world's finest automatic weapons. The MG42's 1,200 round per minute rate of fire had become a source of pride, proof of German technical superiority. Discovering that American weapons delivered more effective firepower, despite lower rates of fire, shattered fundamental assumptions about military effectiveness. Feldwebel Otto Kraus, veteran machine gun instructor with the 2nd Panzer Division, encountered his first M2 during the Battle of the Bulge in December 1944. His after-action report captures the psychological transformation experienced by German soldiers. We prepared our positions according to doctrine, establishing overlapping fields of fire with our MG42s positioned for maximum effectiveness. When the Americans attacked, we opened fire at 600 meters with devastating results. But their return fire was unlike anything we had experienced. Individual rounds struck our positions with explosive force, destroying sandbag protection and penetrating log barriers that had stopped all previous small arms fire. The sound was terrifying, like continuous thunder rather than normal machine gun fire. Our positions, carefully prepared and considered impregnable, were systematically destroyed by weapons we could not see. Within minutes, positions that had taken hours to prepare were rendered untenable. We were forced to withdraw, leaving behind weapons and equipment we could not replace. The Americans advanced immediately, their machine guns providing covering fire that made counterattack impossible. We had been outgunned by weapons we did not understand, deployed by enemies we had been taught to despise. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The winter of 1944 became a laboratory for comparing German and American machine gun effectiveness under the harshest possible conditions. German forces, defending prepared positions with excellent fields of fire, found themselves consistently overwhelmed by American firepower. The mathematical advantage provided by M2 machine guns proved decisive in engagement after engagement. German machine gun doctrine emphasized tactical superiority through superior positioning, crew training, and mechanical reliability. These advantages had proven decisive against Soviet, British, and earlier American forces, but the firepower differential created by M2 deployment negated traditional German tactical advantages. Crew training could not overcome the simple mathematics of effective firepower. The material reality was stark. German MG42 teams could engage effectively to 800 meters under ideal conditions. American M2 teams could engage effectively beyond 1,500 meters under similar conditions. More critically, American rounds retained lethal effectiveness at ranges where German bullets could barely penetrate wooden barriers. The engagement envelope had shifted decisively in favor of American forces. Oberleutnant Wolfgang Schmidt of the 12th SS Panzer Division experienced this firepower differential during the fighting around Bastogne. His tactical assessment, written after capture in January 1945, provides insight into German tactical adaptation. We learned to avoid direct confrontation with American heavy machine guns. Traditional assault tactics became suicidal when the enemy possessed weapons that could penetrate our best available cover. We adapted by emphasizing infiltration, night operations, and indirect approaches. But these methods required time and planning that battlefield conditions rarely permitted. More critically, they reduced our own firepower effectiveness, forcing us to accept unfavorable casualty ratios in most engagements. German ammunition shortages compounded the firepower disadvantage. By early 1945, German machine gun crews were rationed to specific round counts per engagement. American crews showed no evidence of similar constraints, maintaining sustained fire for extended periods. German soldiers began collecting American ammunition when possible, not for analysis but for actual use in captured weapons. The desperation of this expedient was not lost on German military leadership. General Major Kurt Meyer, commanding the 12th SS Panzer Division, noted in his memoirs, "We had reached the point where our soldiers preferred captured American weapons to their own. The MG42, symbol of German engineering excellence, was being abandoned in favor of enemy equipment whenever possible. This represented more than tactical adaptation, it was admission of fundamental technological defeat." The final months of the war saw increasingly desperate German attempts to counter American firepower advantages. New machine gun designs were rushed into limited production, but material shortages and manufacturing constraints prevented meaningful deployment. The MG45, designed to exceed M2 effectiveness, remained largely experimental due to production difficulties. German forces in the West developed new tactical doctrine, specifically designed to minimize exposure to American heavy machine guns. Training manuals from March 1945 emphasized indirect approaches, night operations, and the use of terrain to avoid direct fire engagements. The Wehrmacht, once confident in its ability to engage enemy forces directly, had been reduced to avoiding combat with weapons they could not match. Captured German documents from the final weeks of the war reveal the extent of technological demoralization. A Wehrmacht training circular dated April 10, 1945, stated bluntly, "American heavy machine guns represent firepower that cannot be matched with available German weapons. Direct engagement will result in unacceptable casualties. Emphasis must be placed on avoiding detection, achieving surprise, and withdrawing before American firepower can be brought to bear." This represents a complete reversal of German military philosophy. The Wehrmacht that had conquered Europe through aggressive tactics and superior firepower had been reduced to defensive measures designed to avoid American technological superiority. The machine gun, symbol of German military excellence, had become proof of American industrial dominance. The final revelation came not from technical analysis or battlefield experience, but from the simple mathematics of industrial production. On May 8, 1945, as Germany surrendered unconditionally, Wehrmacht forces across Europe began the process of inventory and surrender. What they discovered in American equipment depots shattered any remaining illusions about the conflict they had just lost. Obergefreiter Klaus Mueller, the same soldier who had first encountered the captured M2 at Arnhem 8 months earlier, found himself supervising the surrender of German weapons at a collection point near Hamburg. Across the field, American forces were cataloguing their own equipment before shipment home or reassignment to Pacific operations. Mueller counted M2 machine guns, stacked in rows of 50, extending beyond his ability to see the end. An American sergeant, speaking broken German, mentioned casually that this represented surplus equipment from a single infantry division. Mueller performed the mathematics: more M2 machine guns in one American unit's surplus than the entire German army had possessed of all types combined. The numbers told a story that German military leadership had refused to acknowledge throughout the war. American wartime production of M2 machine guns exceeded 200,000 weapons, supported by over 5 billion rounds of 50 caliber ammunition. German production of all machine gun types combined reached approximately 750,000 weapons, supported by dramatically smaller ammunition quantities due to material shortages. But the production figures revealed only part of the disparity. American weapons were built to standards that allowed decades of reliable service. German weapons, manufactured under wartime constraints with substitute materials, showed significant wear after months of use. American ammunition maintained consistent quality throughout the war. German ammunition quality declined steadily as strategic materials became unavailable. Major Wilhelm Hartmann, the logistics officer who had studied captured American supply documents, spent his final weeks of the war compiling comprehensive analysis of the logistical defeat Germany had suffered. His report, completed in a prisoner of war camp in July 1945, provided the most complete assessment of German failure to understand American industrial capacity. We fought the war as if it were still 1914, when individual weapon quality and tactical excellence could overcome material disadvantages. The Americans fought it as an industrial conflict where production capacity determined outcomes. We optimized for tactical efficiency. They optimized for strategic overwhelming force. Our MG42 was technically superior to their M2 in rate of fire and mechanical elegance, but they produced 20 M2s for every MG42 we manufactured, supplied each with ammunition quantities we could not match, and supported them with logistics that treated weapons as expendable equipment rather than precious resources. The defeat was inevitable, not because German soldiers were inferior, but because we fought against a nation whose industrial capacity could replace losses faster than we could inflict them. Every German machine gun destroyed was irreplaceable. Every American machine gun destroyed was already replaced by 3 more coming off production lines. The psychological impact on German veterans extended far beyond the immediate war's end. Men who had served as machine gunners faced the reality that weapons they had considered the pinnacle of military technology were obsolete. The MG42, symbol of German engineering excellence, had been surpassed not through better design, but through superior production methods, applied to more powerful concepts. Hauptfeldwebel Wilhelm Gross, whose detailed reports had first documented M2 effectiveness, reflected on the experience in a 1953 interview with American military historians. "We were craftsmen facing an industrial assembly line. Our weapons were works of art, individually fitted and precisely manufactured. Theirs were products of mass production, designed for replacement rather than preservation." The irony was that their mass-produced weapons proved more durable than our handcrafted ones. They achieved superior reliability through different methods, building weapons robust enough to function despite loose tolerances rather than precise enough to require perfect conditions. We learned that modern warfare rewards quantity and logistics over individual excellence. The finest rifle in the world is useless without ammunition. The most skilled soldier cannot overcome enemy firepower that exceeds his own by orders of magnitude. The technological lessons learned from M2 encounters influenced post-war German military development. When West Germany established the Bundeswehr in 1955, planners emphasized avoiding the firepower disadvantages that had proven so costly in World War II. German forces would never again enter combat with weapons inferior to their opponents. The MG3, adopted as standard Bundeswehr machine gun, represented evolution of MG42 design but incorporated lessons learned from American weapons. Manufacturing emphasized reliability over precision fitting. Ammunition supply received priority equal to weapon production. Most significantly, German doctrine abandoned the conservation mentality that had limited MG42 effectiveness. Soviet military planners drew similar conclusions from captured German reports about American firepower superiority. The AK-47, designed in 1946 and perfected through 1947, incorporated lessons about mass production reliability learned from studying both German precision weapons and American industrial designs. Soviet doctrine emphasized overwhelming firepower delivered by weapons designed for mass production rather than individual excellence. The influence extended to American military development as well. Post-war analysis confirmed that M2 deployment had provided decisive tactical advantages throughout the European theater. The weapon's effectiveness validated American design philosophy, emphasizing robust construction, powerful ammunition, and industrial-scale production over individual weapon refinement. M2 Browning machine guns remained in American service throughout the Korean War, Vietnam conflict, and into the 21st century. The basic design proved so successful that modifications rather than replacement characterized its evolution. Total production exceeded 3 million weapons, making it among the most successful military designs in history. The contrast with German machine gun development could not be more stark. The MG42, despite its technical excellence, disappeared from major military service within 2 decades of the war's end. Its complexity and manufacturing requirements made it unsuitable for the industrial-scale conflicts that characterized the Cold War period. Klaus Mueller, the German machine gunner whose encounter with the captured M2 had begun this technological revelation, emigrated to the United States in 1952. Working as a machinist in Detroit's automotive industry, he encountered production methods that explained American wartime manufacturing superiority. In a 1978 interview with oral history researchers, Mueller reflected, "In Germany, we built weapons like furniture, each one carefully crafted by skilled workers who took pride in precision. In America, they built weapons like automobiles, each one designed for reliable mass production using standardized methods. The difference was not quality, but philosophy. We believed superior craftsmanship would overcome numerical disadvantages. They believed superior production methods would create overwhelming numerical advantages. The war proved which philosophy was correct for industrial-scale conflict. When I worked in American factories after the war, I understood why we lost. They could produce anything in quantities we considered impossible, not because their workers were better, but because their methods allowed unskilled workers to achieve results that required master craftsmen in Germany. The M2 Browning's impact extended beyond immediate military applications. Its 50 caliber ammunition became standard for numerous weapons systems, creating logistics advantages that multiplied its effectiveness. Aircraft guns, anti-aircraft weapons, and specialized rifles all used the same ammunition, simplifying supply chains and reducing training requirements. German forces had optimized individual weapon systems without considering broader logistical integration. The MG42 used unique ammunition shared with no other major weapon system. When MG42 ammunition ran short, no substitute was available. When 50 caliber ammunition ran short for M2 machine guns, stocks intended for aircraft or anti-aircraft weapons could substitute. This integration reflected systematic thinking about warfare that characterized American military planning. Individual weapons were designed as components of larger systems optimized for sustained operations rather than tactical excellence in isolated engagements. German weapons achieved superior performance in specific roles, but lacked the flexibility and logistics integration necessary for prolonged conflict. The final assessment of M2 versus MG42 effectiveness must consider not merely technical specifications, but strategic context. In purely technical terms, the MG42's 1,200 round per minute rate of fire exceeded the M2's maximum 600 rounds per minute. German engineering achieved mechanical elegance that American designs did not match. But warfare is not conducted in laboratory conditions. The M2's devastating ammunition, robust construction, unlimited logistics support, and mass production advantages created tactical superiority that transcended technical specifications. American machine gunners could engage targets the Germans could not reach, penetrate protection the Germans could not overcome, and sustain fire the Germans could not match. The broader lesson transcended machine gun comparison. World War II proved that industrial capacity, properly organized and applied, could overcome traditional military advantages. Superior training, tactical doctrine, and individual weapon quality became secondary factors when enemies possessed overwhelming material advantages. German military culture had emphasized individual excellence, precise execution, and technical sophistication. These advantages had proven decisive in conflicts where material resources were roughly equal. Against an enemy whose industrial capacity could produce superior weapons in unlimited quantities, such advantages became irrelevant. The machine gun crews who first encountered M2 fire in 1943 had experienced a preview of future warfare. Conflicts would be decided not by superior soldiering or tactical brilliance, but by the capacity to produce and deploy overwhelming firepower. The age of the craftsman warrior had ended. The age of industrial warfare had begun. American veterans of these encounters drew different lessons from the same experiences. Staff Sergeant James Patterson, whose M2 crew had destroyed Klaus Mueller's section at Arnhem, reflected in a 1985 reunion speech, "We had better equipment, better supply, better support." But those German soldiers were brave men fighting with everything they had. If they'd had our weapons and ammunition, the war might have lasted years longer. The difference wasn't courage or skill, it was industrial capacity. America could build more guns, make more ammunition, and replace losses faster than Germany could inflict them. We won because Henry Ford and Detroit could outproduce Krupp and the Ruhr Valley. I respected those German machine gunners. They fought hard with inferior equipment and never gave up until their government surrendered. But they were fighting against America's factories as much as America's soldiers. No amount of courage can overcome that kind of material disadvantage. The statistical analysis supports this assessment. Conservative estimates suggest M2 machine guns were responsible for 15 to 20% of German casualties in the Western theatre, despite representing less than 3% of American weapons deployed. The firepower multiplication achieved through superior ammunition and logistics created tactical advantages that German forces could never overcome. Post-war studies by both German and American military historians reached similar conclusions. The M2 Browning had provided American forces with decisive advantages that influenced every major engagement. German attempts to counter these advantages through tactical adaptation, superior training, or defensive positioning had failed consistently. The weapon that Klaus Mueller encountered in that abandoned foxhole near Arnhem represented more than superior engineering. It embodied a completely different approach to warfare, one that emphasized industrial production over individual excellence, logistics capacity over tactical brilliance, and systematic overwhelming force over precise limited applications. By May 1945, as German forces surrendered across Europe, millions of German soldiers had learned the same lesson Mueller discovered that September morning. American industrial capacity had produced weapons that German industry could not match, supplied with ammunition German logistics could not provide, supported by production methods German manufacturing could not duplicate. The MG42 remained an excellent weapon, testimony to German engineering skill and precision manufacturing, but excellence in individual systems could not overcome systematic advantages in production, logistics, and strategic material application. The war had been decided not on battlefields but in factories, not by tactical superiority but by industrial capacity. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The final irony was that German soldiers, who had entered the war confident in their weapons' superiority, ended it, preferring captured American equipment whenever possible. The nation that had pioneered automatic weapons development found its finest achievements surpassed by enemies they had been taught to despise as industrially inferior. Klaus Mueller kept a single .50 caliber cartridge case, recovered from that Arnhem position, for the remainder of his life. It served as reminder of the morning when German military confidence encountered American industrial reality. The brass casing, stamped with American production codes and dated 1944, represented the moment when precision craftsmanship met mass production and lost. In the end, the Wehrmacht gunners who captured that M2 Browning had indeed discovered that no MG42 could match its devastating effectiveness. But they had learned something more profound. In modern warfare, the nation that could build the most weapons would defeat the nation that could build the best weapons. American industry had written that lesson in .50 caliber ammunition cases scattered across European battlefields, from Normandy to Berlin. The age of the master craftsman had ended in the smoke and thunder of machine gun fire. The age of industrial warfare had begun, and Germany had lost before the first shot was fired.